This is how easy soft work. This is a PLC that we are using. Itone Easy E4, and then here you can see we have a project, the programming, simulation, and communication. Then we place our we drag our Etron, and then we just place it here. Then after we place it here, we go to programming, and then if it's the first time you open the programming, it's gonna tell you to select a language. It's gonna give you uh, different languages, so you will choose a language you want. Then so here gonna choose the letter programming or a letter diagram. This is a letter diagram. Letter diagram e bereka ka di-networks ne. From you can see mo di mona hore e ngwe 001 ke network 001 until further network. So this why here kono bona ba ngwe network e ba network number e ba dingwala here re na re programmile from network 1 go fihla ka network 16. You kono bona mona kono scrolla go tlase go fihla ko the last network e re programming, which is network 616. So in our experiment, they were asked how to design a traffic light system. Here a smart traffic light control system with pedestrian and emergency overriding using a PLC, e.g. Eton. So we say Eton E4. So they say objectives here or project must be vehicle flow, pedestrian buttons, emergency vehicle override, the night and nighttime low traffic mode. And then they give us everything here. They say, okay, in our PLC, what if you add inputs here? What we must put our inputs, and then they give us device name, description, and PLC input examples. Like example, basically, for button 1 up to button 4, description I think into a pedestrian crossing button 1 per road, and then from input 1 up to input 4, and then for emergency switch, which is button number 5, then they call it an emergency vehicle override while go input number 5. And for day night switch, but go toggle between day and night, we use a button or sensor, but we use a button while go input 6. Then vehicle sensor, see K option. Then we go to output. Our output bar rated the LED array 1, 2, 3 red, ambient, and green, and get 3 per direction. So the 12 from output 1 up to output 12. Eba re lokela a buzzer for what description of the pedestrian crossing ko output 13. Eba re lokela ambient a flash is a flashing night mode. You want to know little flash when it's night. Go output 14. So here we like standard logic programming. But our second year na something 30 second green, 5 second ambient, and 5 second red. Then it's a traffic flow. Then they say we must use timers like TON, TOF to create delays. Then we finish here. They say we must state mechanical logic or a counter-based sequence. Okay, it's fine. We already stated this one. And they talk about pedestrian crossing, but when a push button is pressed, finish current green phase. Well, green phase, it must be finished first before pedestrian cross, and then well, after toggle pedestrian signal, well, red for vehicles, all lights must be red, and then buzzer, and then pedestrian crossing. Buzzer and green for pedestrian. Then they say resume from a normal circle. Then after resume a normal circle, then they give us explanation for emergency override. Then they give us for time for night mode Q14 on and off for every 1 second. Every 1 second. Then they give us more information that we can use for green timer, ambient timer, and red timer. they give us here. Then they give us that component, then let us leave it. Then let's go to our picture. Here in our picture, we design a simple logic for how our system it will work using a portals. So look at our four road, north, in and south, east, in and west. Then from west and from east. So those roads they work as full. North north iberekale south because of the opposite. East iberekale west because of the opposite. So that means when it's green in west, it will be green at east, and then it's gonna be red both at south and north. When it's orange or ambient, then it's gonna be ambient all from all thing, because of before the system can change from red to green, must be, and orange must be between. From green to red, orange must be between. Either way around. And then if it is red at west, there must be red at east, and there must be green at north and green at south. This is how our system works. So now let's go to our logic. Yes, this is our logic again. Then we're gonna start here at the top in our logic in network 001. In network 001, stability or stable emergency button. Then when we have a button 5, and when we press it store a memory into this coil, which is memory 2, and then we have day and night switch, and then we have it button, and when we press this button, it store a memory into this coil, memory coin 4, and then we have a timer for day and night switch, which is flashing, you can see here, and then it is every 1 second. It's flash for every 1 second. And then we have pedestrian buttons. All pedestrian buttons are in parallel. When you press each and one of it, it's gonna store the memory here in memory array. Whether you press pedestrian button 1, 2, 3, or 4, or you press 1 and 2, or all of them, they're gonna store a memory in this coil, which is called memory array. And then this is a logic for a pedestrian. Then it will take an information from memory array, and then gonna take it and then do a logic, and then put that logic in memory 6, and then gonna take that what is inside the memory 6, and then continue with it here, and then to put an output of Q13, which is a buzzer, and then and all those light. Then here we have a timer logic for it, how it the timer delay for those pedestrian button when it's work, and what it must wait for. And then here now we have a traffic light system where our traffic is gonna start. And then if we say memory 2, we in the memory 2 we save a logic for emergency. And then if emergency button here is pressed, gonna save as memory 2, and then it must override the entire system, nothing will work. And then we say if there is nothing in the memory 2, then we can continue. But if there is something, there's a logic that an emergency light is pressed, our traffic light, memory 1 must not work. But if it's not, memory 1 must work. Then memory 1 is the memory that control all the logic for our circuit. This is a logic for our red north and red south, because north and south are working in opposite way, and then green east and green west because they are working opposite way. And this is memory for all ambient light, because of all ambient light must switch on and must switch off. And then this is the logic for an opposite logic after the first logic is the second logic, which this is for green, and then green south and north again, and then east and west again. They are in opposite, they work related to each other. And then this is here is the time delay, like T1, T2, T3, T4. Then T1 and T2 at 30 seconds. T1 is gonna be a delay for red, T2 is gonna be delay for green, and then T2 is gonna be delay for ambient, which is 5 seconds. And again, because of ambient, it must go twice. From red must be ambient, and then from ambient must go to green, and from green must not go straight to red, must be ambient again. That's why ambient have two logics. And then this is a memory logic for emergency button again. Okay, thank you very much. Now let us simulate our project. We come here in the simulation button. We're gonna say simulate, and when we say simulate, it's gonna give us our input buttons here. All input buttons from button 1 up to button 6. These are only buttons that we use. And then on our left hand side, gonna give us a display, and it's gonna tell us display plus buttons. If we click it, you're gonna see display plus buttons. It's gonna say digital input. If we click it, you're gonna see our digital input, all input buttons. Say digital output. If we click it, you're gonna see our output, like all traffic lights from Q1 up to Q12 are traffic light. Q13 is a buzzer. Q14 is the day and night switch. So now, if we go here at the top, below oscilloscope, we're gonna see an run simulation button. Now we're gonna run a simulation, but we're gonna run a simulation. We run our simulation, then it starts by turning red north, red south, which are opposite, and turn green east and green west. So now car passing from east and west only, but north and south are on stationary, as we said here in this picture. So that let us wait. Then we're gonna wait for 30 seconds for our system to change to ambient, because of we are here at the time 1. Now we are at the time 2. Our system now is here changing to an ambient. We are on now, after a second we are on this one for 30 seconds again. You see our system is changing to an opposite logic: green north, green south, and then others are red. Green north, green south, red east, red west. Then again, and when it's changed again, it's gonna come here to the second ambient again. When it's finished this 30-second time for opposite logic, now it's here. It's at an ambient. Now it's gonna go back here again. It's gonna loop back from the start. It's gonna loop and loop and loop and loop in sequence until anything is changed. Then what we what we call when we talk about change, we're gonna go up here. We're gonna talk about day and night switch, which is button 6. We're gonna go to the display input. We come in input. We're gonna press our button 6 here. We press it. Our button 6 is pressed. Then we're gonna go again to our output, and we're gonna look what is happening. Here we can see our day night and LED is flashing for each and every 1 second, as we see here. As we see here, we enable Q14. Then we can go back and change. Let's go back, or we're gonna right here that would click here where you say to disable the button, to press it again. Then if we press our button 5, which is emergency here, we press our emergency, it's just pressed, and we go to output. Then our logic are on red. Everything now is on red. Emergency vehicle is passing. We override our system until emergency button is switched off. You can see only emergency is working. To override system, it allows all emergency vehicle to pass there without all vehicle as on stationary. Red is on stationary, south, east and west all are red. From north, east, everything is on stationary until we press again an emergency button. That, and when we press emergency button, now you can see the system is zooming back to its normal. It's working normal like all system. Then when a pedestrian requests a press the button. Our logic is gonna come here, and it's gonna give a pedestrian chance to come and cross, but in a sequential. Now it's turning a buzzer. Pedestrian is crossing. When pedestrian finish, system is gonna go back to normal again. Is on the red now. Pedestrian can cross. The buzzer is on now. After pedestrian cross, system go to normal. On you see pedestrian on all pedestrian is gonna work the same. You see here, even though even we create this the logic like even when I press the button because it's a click button, you have to click it and unclick it. But the buzzer is on, even the button it was just click once because of its follow this logic, and then it store itself into a memory 6, and then in this coil of memory 6, and the coil of memory 6 is looping back, and then this time delay is the time that will interrupt with it. It's gonna give a pedestrian 10 seconds to pass. If they don't pass in 10 seconds, it's gonna switch off, and then the system traffic continue normal. Let's press it and see. You're gonna wait, and then after gonna wait for all cycle to come until it's go to ambient. Let's go to ambient, put all ambient for 10 seconds, allow pedestrian to cross, and pedestrian must cross. If the pedestrian must not cross in 10 seconds, system will go back to normal. Okay, thank you very much. I finished explaining what is happening here. Let me stop the simulation. I think you're gonna find it good. Or